Okay, hopefully you can see my screen there. It should say IGCSE Mathematics 9 to 1 in the front. Can everyone see it? Great, I see some nods. Okay, so today I'm going to try and cover powers, laws of indices, and then I'm going to go to Unit 11 just very quickly to do some standard form work because it ties in really well with the laws of indices we're going to be covering. And then hopefully we'll have time to also look at some Surds, which is higher topic only. So I'm going to cover mainly foundation, but the higher end of the foundation work, but also move slightly into the higher course. And then the Surds is just going to be higher work only. So if you have any questions, please feel free to just raise your hand or put a question in the chat. I did have the chat. Let me just open the chat. There we go. Okay, so let's go ahead and start. All right, so just a quick warm up then. I'm hoping that you can come up with some answers to this question for me and fill in the two blanks there. So we have a number raised to the power of something. We'll always give the answer something. So just have a think. Doesn't matter if you don't know it, that's absolutely fine. I actually think there's two different answers that could work here. So just have a think about what you think that answer could be. A number raised to the power of something will always give the answer something. This is one of the most fundamental laws of indices that you need to know. So if you don't know it now, that's the main takeaway from this lesson I want you to have at the end. So if anyone wants to be brave and type in the chat what they think the answer might be, go for it. But I'm not going to expect anyone to do that. It's up to you. Okay, let's give you a minute to have a think. Any thoughts? Anything coming up? Oh, amazing! Someone's written it on. Excellent. I don't know who did that, but I'm really impressed. Okay, cool. Yeah, absolutely. That's the first one that I was going to say. So a number raised to the power of 0 will always give the answer 1, and that's the most sort of fundamental thing you really have to remember. However, there is one exception to this. Does anyone want to be really great and tell me what this one exception is? There's one time when this doesn't work, one number when raised to the power of 0, it will not give the answer 1. Anyone got any thoughts on what that might be? No? Okay. So there we go. That was my answer, 0 and 1 and 0. Excellent. Sophia, well done. So yeah, absolutely. This will work for every value except for 0 itself, okay? And then the other answer, which I thought some people might come up with, which is also true, is that a number raised to the power of 1 will always give the answer of itself, okay? So for example, if we raise the number 3 to the power of 1, it's just going to be 3, okay? So hopefully those are two things that you have. And if you didn't know that, make sure that you remember that for me, because that's one of the most important things for you to remember. Okay, I am going to just clear those drawings a second, and then we can move on. There we go. Okay. Okay, so what are powers? Just a quick recap. I'm hoping you know this. You also will see them as indices, and we're going to work through the laws of indices today. So a power is simply a way of writing something like this, 5 times 5 times 5 in a shorthand way, so 5 to the power of 3. Okay, so if we had 6 5s here, if it was 5 times 5 times 5 times 5 times 5 times 5, it would be 5 to the power of 6. Okay, the 5 we've got there, the big number, is the base. And then the power or index is the little number that goes at the top, the 3 there. So we've got 5, we would say this as 5 raised to the power of 3. And we can only simplify these if the base numbers are the same. So really important there. Let's have a look at, for example, if we have 5 times 5 times 5 times 2 times 2 times 2 times 2. So we would only be able to simplify those 3 5s there and make that 5 to the power of 3. And we can simplify the 4 2s and make that 2 to the power of 4. But we can't actually put those two together. We couldn't say it was, say, 10 to the power of anything. We can only simplify if the base number is the same. Okay. Right. So that's powers. Let's just quickly talk about what are roots. And a root is simply the opposite of a power. So for example, if we know that 2 to the power of 2, which is 2 squared, is 2 times 2, is 4, then the opposite of that, the square root of 4 there, is 2. Okay. Anyone got any questions yet? No? Okay, I haven't seen any questions yet, so I'll keep going. If we say 4 to the power of 2, so that's 4 times 4, is 16, then we would say that the square root of 16 there is 4. And this works for all roots. So we could say, for example, 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. The fourth root of 16 there is 2, okay? So it's just working in the opposite way. All right. So let's have a think about some algebra there. So how do we use powers of algebra? For example, we have a times a times a. And it works in exactly the same way. We would just say now that this is a to the power of 3, where a is the base number and 3 is the power there. And in the same way as with numbers, we can only simplify this if the base letters are the same. So if we have a times a times a, that's a to the power of 3. B times b times b times b, that's going to be b to the power of 4. So we've got a to the power of 3 times b to the power of 4. And we cannot simplify that any further. It's just going to be a to the power of 3, b to the power of 4 there. Okay. So that brings us quite nicely onto our laws of indices, which is the first main topic I want to work on today and to do some actual maths with. Okay. Now, what are the laws of indices that you need to know? I'm going to bring up the most important, the first 5 of them for you here, and then we'll work through them individually. So the first one, the law of indices that you need to know, is the law of multiplication. That's the fact that a to the power of m multiplied by a to the power of n is going to be given as a to the power of m plus n. So if we're going to multiply the bases with different powers, we simply add the powers there. That's the first law of indices. The next one, in the reverse of that, is a to the m times divided by a to the n is a to the m minus n. I used to get my students in year 8 to write raps on this because it sounds so good in a rap. Like a to the m divided by a to the n is a to the m minus n. They used to have a lot of fun doing that. So third law of indices is the law of brackets there. So if we've got a bracket, a to the power of m, brackets to the power of n, then we multiply the indices. Okay, so that would be a to the power of m minus n. I know this is a lot of information. We're going to do some maths with this in a minute. So please don't worry that I'm going through quite quickly. We'll come back to each one. And then the last 2 are the ones that we talked about at the beginning of the here. So anything raised to the power of 1 is itself, and anything raised to the power of 0 is 1, of course, except for x is 0. 0 raised to the power of 0 is actually an undefined value. So we cannot say that it works for all values because it doesn't work for 0. Okay, so you need to learn these 5 rules. You're going to need to use them for your exam. So really important to have them jotted down. And I'm going to take you through each one individually and we'll just practice using some. Okay. So the first one, the law of multiplication. Let's have a look at a really simple example here. If we've got a to the power of 4 and we're going to multiply that by a to the power of 5. Sorry, I should have went a bit quickly then. I should have given you a chance. That's going to be a to the power of 4 plus 5. We add the powers together. So we're going to get a to the power of 9 there. Okay. Well done. Oh, great. In the chat, I see students written 8. Stuart's written a to the power of 9 there. So that's great. Well done, Stuart. And let's have a look at an example for a division there. So we've got a to the power of m divided by a to the power of n. So let's have a look at an example. A to the power of 7 divided by a to the power of 3 is going to be, and we can also see this written as a fraction. So you probably in your exam more likely see it written as a fraction here, and that's going to be a to the power of 4 there. Okay, so we just subtract the power and great, well done, 70. We've got 7 minus 3, which is a to the power of 4. Okay, I'm going to give you all a chance to have a go at some questions like this in a moment. So sticking with those 2 rules, if there are numbers with them, like this, you see 2a to the power of 4 times 3a to the power of 5. We're going to work with the numbers separately, and then we're going to do the algebra separately. So at this point here, you're going to want to bring the numbers together. We've got 2 times 3. And then we're going to want to bring the algebra together and work out that a to the power of 4 times a to the power of 5 there. So does anyone want to have a go at this? I know it's not that easy to write in the chat, but you can have a go. So we've got 2 times 3, which is 6. And then a to the power of, oh, I've got someone going for it. Nice, brilliant, well done. Yeah, excellent. And then someone else in the chat has written 6a to the power of 9. Well done. Great.
Well done. That was Sophia. Well done writing on that. If people
That's really impressive.
We were rehearsing doing that for you and hadn't thought about, that's amazing. And we can talk about how to do that later if other people don't know, but well done, Sophia.
Yeah, because it's nice to see that actually. Yeah, so absolutely, you're perfectly correct. So we've got 2 times 3 is 6. And a to the power of 4 times a to the power of 5, add the powers there, 6a to the power of 9 there, okay? I am just going to clear them though, so that we can, but that was great. And let's do one with division. So you may see it written like this, or you may see it written like this. It means exactly the same thing, okay? So deal with the numbers first, deal with the powers separately. We've got Sophia. Great, and also a couple of people in the chat have got it right as well, so brilliant, well done, okay? So 8 divided by 2 is 4, and then a to the power of 7 divided by a to the power of 3, subtract those powers, we've got a to the power of 4 there, okay? So let's have a go at doing some of these in my first poll, if I can get this to work. Can you, hopefully you can see a question.
Don't write on the screen here. That we should say that, because we're going to do this as a little bit of a poll. Like, you sit and see if you come up with the answer. Sorry, I'm jumping in, Amber. Do you want to?
No, great. Yeah, no, really good point actually. So so yeah, I'm gonna launch my first poll in a moment if I can work out how to do it and make sure I can do that.
Yeah, so don't do it in the chat or don't do it on the screen. Just work it out for yourself. And then when we launch the poll, it'll come up with you can put in A, B, C, or D, and then we'll show you the results. Yeah.
So figure out in your head which one you think the answer is. Hold the letter in your head. It's either going to be A, B, C, or D. And in a moment, I'm going to launch the first poll. And hopefully you can all give me the answer. So.
And tell us if we don't give you enough time too. We're figuring out how well this bit works too. So you're testing it with us in a little bit too. So
okay, so I should have just launched that poll now. Can you see it? Oh yes, I've got an answer already. Okay, so think about the law. I've got fantastic. Yeah, okay, and almost everyone's got that correct. So oh wait, no, there's more people coming in.
Yeah, so this, I'm going to give a little Amber. So what see how you see the numbers. Amber and I can see it going on, but we still can't see which of you. It's still anonymous to us, so don't worry.
I can see now. Yeah,
but so you see it's got 11 of 12 people participating. You and I are the other 2. So if it gets to 12, or even now, what you can do is now you could end it and share the result.
Brilliant.
And tell people too.
So
for the recording, we can say what the results are.
Doing well. We've got 73% correct on that one. So the answer was C. So fantastic. Well done. Okay. Just a quick recap. So we're going to, because we're multiplying the base here, we're going to add the powers for this one. Okay. So we've just basically got A times A here. So that's 2 lots of A. A times A times A times A here. That's 4 lots of A. So in total, there's 6 lots of A there. Okay. So that's A to the power of 6. So I'm going to do that again.
I ended the sharing, so they're not seeing the poll pop up. Just you and I are. You're getting some of the behind the scenes stuff here too, you guys, of how this works. I don't know if some of you Zoom in your day-to-day life and you know how these things work, but.
Okay, hang on. I need to work out how to relaunch it now. So.
I can do it. Do you want me to do it, Amber? You got it. Perfect.
Is that launched now? Yeah. Okay, great. So I don't know if did I give you enough time to do that one? We've got quite a lot of people answering, so that's good. Fantastic. It's looking really good. All right, brilliant. Yeah, so we've got almost everyone's answered and almost everyone's got that correct. So that's absolutely fantastic. So I can end that, share the results again. We're getting there with this now. And yeah, absolutely. The answer this time was a to the power of 8 there. So I'm going to add the powers there, a to the power of 8. So fantastic. Let's have another go. So we've got some numbers on this one. So I'm going to give you a little bit longer to think about it. It's great. I can see some people sort of putting pen to paper, so it gives me an idea of how long it's taking. So I'm going to relaunch it now. Okay, so hopefully that should have worked. And I can see loads of correct answers already, so that's looking fantastic. I love this. It's great. Okay, all right, brilliant. So we have got 2 times 5, which is 10, and then a to the 2 times a to the 4, which is a to the 6. So the answer was D, and I can share the results there with you, and you can see that we've got 91% correct. So brilliant, well done. So just to quickly go through that one, 2 times 5 is 10. So we're going to do the numbers separately. A squared times a to the 4. So we add the powers, that's a to the 6 there. Okay. And I've got a division 1 for you to have a go at. So remember the, oh, don't want to relaunch it yet, do I? Just give you a moment. Okay, I'm going to do this. All right, we've got a bit of a split answer there. So we've got some people saying B and some people saying D. So let's have a look. So we're going to divide the base numbers, but remember the law of division is that we are subtracting the powers there. So actually it's going to be a to the 20, and then we're going to subtract that 5 from the power. So it's going to be a to the 20 minus 5, which is a to the 15. So D was the correct answer there. A few people put B, so a few people have divided the powers there. So just remember, it's a really easy mistake to make, but just remember that law there. Think about this as 20 A's, and then we're dividing that by 4 lots of 5 A's, essentially. So we've got, we're going to cancel out the 5 of those A's from that fraction, okay, being left with 50 A's, if that makes sense, 15 A's. Let's try that one again. Let's try another one again. There's the results. Stop sharing. And then I'm going to go to the next one, and hopefully, okay, so we've got a number on here, and again, the same, using the same law, using the law of dividing. And I'm going to launch that now. Okay. Super. Yeah, amazing. It's looking much better now. We can, I think that's everyone. So I will share that now. And we've got 91% correct. So fantastic job. Well done. 8 divided by 2, we do divide the numbers normally, so that's 4, and then a to the power of 12 divided by a to the power of 4 is going to be a to the power of 8. Okay, so it's looking great. Well done. I think we might have one last one, which I've just put a little times and divide in there just to make it a bit more exciting. Okay, I'm going to launch. Hopefully you've got your number, A, B, C, or D in your head. Relaunch that. Okay. This is a bit of a tricky one, this one. So let's see. Great. Okay. Got 11 people, so that's fantastic. All right. And 73% correct. So I'm going to say that's a pretty successful. Well done. So share those results there. And I'll just quickly go through this one with you. We've got 2 times 8, that's 16. In fact, I could even write it on here. Okay, so we've got the 2 times the 8, which is the 16 there. Okay, a to the power of 2 times a to the power of 4, so that's a to the power of 6 there. Dividing by, I like to look at my dividing as a fraction there. Okay, divide that by 4, a to the power of 3. And then 16 divided by 4 is 4 there. A to the power of 6 divided by a to the power of 3, subtract the powers there, so it's a to the power of 3. And as you can see, we've got 73% of you have said it was B, so fantastic, well done, really great job. Okay, I'm going to move away from that now for a moment. We'll come back to that in a moment. So that was the first 2 laws of indices. Then there was another one, which is the law of brackets. Okay, so that's basically we're saying, and I'm just going to quickly write out what's going on here, because imagine we've got a to the power of 3 and we wanted to square that. We'd essentially be saying that was a to the power of 3 times by a to the power of 3, wouldn't we? Okay, and so using the law that we just talked about, the law of multiplication, it would be a to the power of 6. 3 plus 3 is 6 there. But you can see that we could go straight from there to there by simply using this law. That's going to be a to the power of m times n. So it's exactly the same as a to the power of 3 times 2 there. Okay, so law of brackets is where we do multiply the powers. All right. And I've probably chosen the same example. Oh, almost the same example. Clear these. A to the power of 4 times a to the power of 4, all of that to the power of 2 is going to be a to the power of 4 times 2, which is a to the power of 8. One more example here with a number in it there. Don't forget to do the numbers. For some reason, in a GCSE exam, all of the ones I mark, very, very easy. People forget to put the power on the number there. So don't be fooled by that. Remember to put the power on the number as well as on the letters there. Okay, so this is going to be the same as 2 to the power of 3 multiplied by x squared to the power of 3, which is x to the 2 to the power of 2 times 3. We can actually work this out. 2 to the power of 3 is 8, and x to the power of 2 times 3 is x to the power of 6. Okay. And I'm going to redo that. I'm going to go back to my poll. So here's one for you to have a go at. I'll give you just a moment to have a go at this one. And let's relaunch that poll. Here you go. Remember A, B, C, or D. Good. Just a couple of people haven't answered. All right, I'm going to end that, and that was amazing. Got 100% correct there, so well done. Really, really good. Everyone that took part got the right answer. Fantastic. Okay, here's another one with a number in, so for you to have a go at. You ready for me to relaunch that? Okay, I'm going to do that now. Here we go. A, B, C, or D, take your pick. Some people are really quick here. All right, got a little bit of a mixed bag here from people who have answered. Couple of people have done that really easy thing to do that I just said about and forgotten to square the number there. So because that number is inside the bracket as well, we have to square the number as well as doing the algebra there, okay? So we just had a few people doing that. So 5 squared there is going to be 25, and then a to the power of 3 to the power of 2 is your a to the 6 there. So I think the algebra wasn't the problem there. I think it was the number bit that people forgot. So I'm just going to what everyone answered. Well done. So we've got 55% correct there. So we'll hopefully get another one of those. I'm hoping there's another one we can have another go at. Oh, it's a bit more challenging though. All right, I'm going to give you a little bit longer to work on this one because it's a little bit more challenging. Don't forget about the 2 in the brackets there. Okay, so if you have an answer, just double check you've remembered the 2 in the brackets, double check you've remembered the brackets rule here, and double check you've remembered the multiplication rule when you're going across there. So there's quite a lot to think about there. Doesn't matter, no one will know if you get it wrong anyway. Okay. All right, are you ready for me to launch that poll? Let's do this. All right, so got a lot of correct answers coming in. That's really, really great. Okay, fantastic. Yeah, so all right, so we've got 50% correct answer, which is actually, I'm really impressive because it was a really tricky question. I'm just going to go through this before I share that. So what we've got here, where's my pen? There's my pen. Okay, so I think the thing that most people will forget is that it's 2 to the power of 3 there. So we've got the 2 inside the brackets. So we have to remember that that's 2 to the power of 3. And then we've got a to the power of 5 times 3 there. And all of that then is going to be multiplied by 3a to the power of 4. So I'm not going to do anything with that at the moment. I'm just going to tidy this bit up. Now 2 to the power of 3 is 8. So it could be that some of you thought maybe that was 6 or something. 2 to the power of 3 is 8. 2 times 2 is 4. 4 times 2 is 8. A to the power of 5 times 3. So that's a to the power of 15 there. And then we're going to multiply all of that by 3a to the power of 4. And we are going to then have to do a little bit of more, quite a lot of times tables here, I'm afraid. 8 times 3 is 24. A to the power of 15 times a to the power of 4. Add those powers, we get a to the power of 19. So the answer, correct answer there was C. Has that explained it clearly enough? If anyone, you can pop in the chat if you would like me to explain that again, or I can't see everyone's faces, so I don't know how. Okay, all right. Okay, so well done, really great there with that one. Okay, And that was a tricky one to end on there. So I'm just going to clear that and move on there. Oh, turns out there was one more, sorry. Last one, very, very quick one, just to check you've got that last. This was my first question that I asked you. And I'm going to launch that poll straight away because it should be quite a quick one. A to the power of 0 is it A0, B1, CA, or D infinity? Okay, so 9 out of 11 people have got that correct. Well done. So the answer is 1. A to the power of 0 is 1. I should have said if A isn't 0. Okay, but yeah, A to the power of 0 is 1. So well done. That's just a memory thing. I'm afraid you've just got to remember that. So I just thought I'd throw it in there as a quick reminder. There. So yeah, anything to the power of 0 is always going to be 1. Okay, we'll come back to that later, probably. All right. Okay, so this is moving more into towards the higher end of it. It's still on the foundation paper, but more on the higher paper. So we've got negative powers. So negative powers are basically anything like a to the power of -2, so 3 to the power of -2, something like that. But we have a special name for raising a number to the power of -1. Raising a number to the power of -1 is called the reciprocal, and that's a vocabulary term that you do have to remember. You could be asked in your exam to write down what the reciprocal of 5, for example, is. So it looks like this. X to the power of -1 is 1 over x. And in number terms, 5 to the power of -1 is 1 over 5. 20 to the power of -1 is 1 over 20. Okay, so raising a number to the power of -1 is called the reciprocal. 100 to the power of -1 is 1 over 100. Okay. And if we're looking at another negative power, so not -1, but minus something else, for example, x to the power of -m, then it's just the same as 1 over x to the power of m. So it's the same as 1 over the number raised to the positive power. Very easy to forget this, and it's a very important rule. If we have 5 to the power of -2, it's the same as 1 over 5 squared. So that's actually 1 over 25. The last one, if we have 20 to the power of -7, 1 over 20 to the power of 7. And I didn't write down what that is because 20 to the power of 7 is a humongous number that wouldn't fit on my PowerPoint. So I left that in indice form for you. Okay. All right, so I'm going to move on now to standard form. Standard form, I'm just going to really quickly touch on what standard form is. This is a way of us giving us a way of writing very big and very small numbers. So, and it uses powers of 10. So those negative powers are useful here because we will use them to write very small numbers. 3 times, oh, this isn't a great example because you probably wouldn't write this number in standard form because it's not a very big number. But just to give you an idea of how it works, is 3 times 10 to the power of 2 is in standard form. We always have this first digit here is going to be something between 1 and 9. It could be a decimal, it doesn't have to be a whole number. And then always times 10 and then to the power of something. So of course that's 3 times 100, which is 300. As I said earlier, it could be a decimal. So we could have 3.5 and then times 10 to the power of 7. Now this one is probably a little bit harder to spot straight away, but it's really important to understand what it is, because if you're sitting in a calculator paper, your calculator will give you a much bigger number in this format because it won't be able to fit all of those digits on the screen. And all this is basically saying it's 3 and a 5. And then you just count. The easiest way to do it is to simply count how many. So that is going to be multiplying it by 10 7 times, essentially. So it's 3.5 multiplied by 10 7 times. So we're going to take that decimal from there, and we're going to simply count 1, 2, and we're going to fill in a 0 for each one that we count, if that makes sense. Okay, so that is actually going to be end up being 3 and a 5 and then 6 zeros, because the 5 will account for the first move of the decimal point, and we add on these 6 extra zeros for each time we move that decimal point. And if I remove my drawing and make that look a little bit nicer, hopefully you'll see it's a 3 and a 5 and then 6 zeros there. Okay, so you can see we've moved that decimal point one move to the right there, and then another 6 moves. Okay, let's have a go at this one. So I'm going to give you a moment just to have a think about what this might be. So we've got 2.12 times 10 to the power of 5. To multiply a number by 10, we move the decimal point one unit to the right, I should say. So this decimal point needs to go 5 units to the right. I'm not going to ask anyone to put anything in a poll, just have a go, see if you get it right or not. And here we go. So it should be, oh, yeah, brilliant in the chat. Thank you, Stuart. 212,000. Okay. Here's another one. If anyone wants to put it in the chat, if they're feeling brave, please do. If anyone wants to unmute themselves and tell us the answer, please do. Or have a go at writing on the screen if you can work out how to. Okay, excellent. Stuart got it right, well done. Okay, so we've got, what is that number? 93,000. Oh wait, hang on a minute. 2,000, 22,000. Yeah, 9,322,000. There we go. Couldn't count it then. There we go. Okay. Here we go. Here's the next one. We're going to speed this up a little bit now. I'm running out of time. Yes, fantastic. Got some correct answer from 70. Just check, there's so many zeros, it's hard to check. Brilliant. So that's a 3 and a 2, and then 6 zeros on the end, 32 million. Okay. I'm going to go the other way. So if we're going the other way, if we have a number and we need to write that in standard form, okay, we're going to simply think about how we would get that decimal point back so that we have a number between 1 and 9 here. And obviously it can be a decimal. So this one is going to be 6.7. And then we just need to think, how many moves have I made that decimal point go? So it's gone 1, 2, 3. So you can see that 6.7 times 10 to the power of 3 there. So let's try, oh my goodness. Okay, I'm going to tell you how many zeros there are because there's a lot. I should have separated them out, my apologies. So that's a 4 and a 3 and 8 zeros. So if you want to have a go at that one in standard form. It's going to be 4.3 times 10 to the power of. Anyone want to write what that power is going to be? Yay, fantastic. Well done, Kira. Okay, so it's 4.3 times 10 to the power of 9. We have to make sure, because some people could, for example, write 43 times 10 to the power of 7. And that wouldn't be correct. It would still be the right answer, but it wouldn't be in standard form, because standard form, this first digit has to be between 1 and 9, okay? So if you were to give me the answer 43 times 10 to the power of 8, although it would still be the correct answer, it wouldn't be in standard form. So it wouldn't pass that question in an exam if the question said, write this in standard form. In case it's really important, that first point there is a number between 1 and 9. Here's another one. There's 5 zeros there, sorry, just to let you know. Okay. So we've got 6.47 times 10 to the power 7. Excellent, Stuart got it in just before me, well done. Yeah, and Semsi, well done. Great, lots of correct answers coming in the chat, so that's really good to see. Right, it's very rare, but sometimes an exam paper likes to see a small number written in standard form just to check you understand the concept. So what would this be? Brilliant, 70, well done, yeah. Oh, actually just sorry, rethink that one a little bit. So it's 2.01, how many places have we moved that decimal point? It's actually just moved 2 places. So 2.01 times 10 to the power of 2 there. And I think everyone's got this now, so I'm just going to put the answer up here. We've got 3.82 and then 1, 2, 3, 4, 5, 6, 7. 3.82 times 10 to the power 7. Great, you got there. Well done. Got in there just in time. Okay, so those are very big numbers. Also, the other thing that can't fit on our calculator is very, very small numbers, okay? So again, I'm just going to explain it with this. If we've got 3 times 10 to the power of minus 2, now remember, this is where our negative powers come in. Remember, 10 to the power of minus 2 is the same as 1 over 10 to the power of 2. I'm going to write that down for you. So this is the same as 3 times 1 over 10 to the power of 2. So that means it's actually the same as 3 divided by 100. 10 to the power of 2 is 100 there, okay? Which means that that's going to be 0.03. So you can see that our decimal point, which started off here, has now moved 1, 2 places. So it's now going to be there. A little bit harder, harder to get the concept with smaller numbers. I might just do one more example. So that was 0.03, clear my drawings there, and then we'll do another one. So what we have here is 2 times 10. Oh, no, to the power of minus 5. So it's going to be 1 over 10 to the power of 5, which is exactly the same as 2 divided by 10 to the power of 5 there. So if we're dividing a number by 10, we move that decimal point 1 place to the left. But we want to do that 5 times because we're dividing it by 10 5 times. So we've got to think how many places is it going to move. So it's going to move 1 across that 2, and then it's going to have 4 more moves, which means we need 4 more zeros. So hopefully the answer there should be 4 zeros and a 2, 0.00002. And we've got a couple of correct answers in the chat, so fantastic. I'm going to give you one to have a go at yourself. Okay, so excellent, Stuart, well done. So we are going to move it across that 3, that's 1, and then 3 more zeros need to meet to give us that move of 4 points to the left there, okay? Let's try another one. I'll try and speed this up a little bit. So we've got 9.322. Really, the question is just how many zeros do we need in front of that 9? Okay, so we need to move that 3 times, 3 points to the left. So it should have just 2 zeros in front of that 9 because that decimal point has moved 1, 2, 3 places. Excellent, well done. And how many zeros do we need in front of the 6? In front of the 3. And hopefully you get that we need 5 zeros. 1, 2, 3, 4, 5 zeros to make that decimal point move 6 points across. All right, and hopefully we've got time. I know I'm running into our question time now to go the other way. So if we're going to do it the opposite direction, we need to think how many places we're moving the decimal point in the other way. So we're going to move this decimal point 1, 2, and 3. So this one is going to be 6.7 times 10 to the power of minus 3. Oh, that should be minus 3 there. My apologies. Probably got the same mistake with all of them. 6.7 times 10 to the power of minus 3 there. Okay. So do you want to have a go at doing this one quickly? Okay. So it's going to be 4.3 to the power of minus times 10 to the power of minus 5. Oh, I did remember the negative there. That's good. Here's another one. Oh my goodness. 1, 2, 3, 4, 5, 6 zeros there. So it's going to be 6.47, and then we are going to have to move that decimal point. Oh, I didn't put the answer in there for some reason, but it would have been 6.47 times 10 to the power of minus 7 there. Okay, and hopefully we have this 2.1 times 10 to the power of minus 1, and this last one. 1, 2, 3, 4. So we had to move it 4 to get to between the 3 and the 8. So 3.82 to the power times 10 to the power of minus 4. And there's the last answer there. Okay. I think I'm going to have to stop it there because I haven't given you any time for questions, which I was meant to do. So unfortunately, we didn't get onto the Surds part, which I'm sorry about that. I think I just planned a little too much for our time.
That's okay, Amber. We can bump it into the next week and adjust that schedule. There's not too much.
I hope so, because I really wanted to do the next Surds or not poll. Yeah, okay. So does anyone have any questions? I should have written questions on here. Okay, Stuart's going to do some Surds as homework. Yeah, I could actually pop some questions in the forum for you. So I did have. So what I could do is I could maybe pop this slide without the answers onto a forum or something, and you can all have a go at doing this, and we could maybe start next lesson with the answers to these questions. Or you could run through the video of this recording and see if you can quickly get to the answers that I just showed you.
I'll say I'll cut that. I can edit that out of the video.
Well, it's nice to know what, yeah. So okay, so I can do that as a little bit of homework. Yeah, okay, great. So what I've done here is I've just put 5 basic questions. If you're kind of aiming for foundation, you want to go for these simple ones, just simplify these. But if you are aiming to take the higher paper for those higher grades, then do have a go at these more challenging ones on this side here. And then next lesson, we can start with this, go through the answers, and then we'll do the Surds as well. Okay. So does anyone have any questions? We've got about 2 minutes.
Any feedback too would be great. Like, was this helpful? Was this good?
Yeah, it would be really great to have feedback, because of course I don't know whether people are aiming for, doing foundation or higher, or what the level is. So if I kind of had an idea of that, it would make it easier to plan. I know everyone's doing different things, but
yeah, lots of positive comments. Yeah. Oh, that's good, Kira. So it makes a huge difference on higher. She's on higher.
Yeah.
So lots of people are saying that's helpful. Good.
Yeah, that's brilliant. There are a lot of rules and a lot of laws to learn, yeah, and I've put a whole topic into one 50-minute lesson, so it's a lot to do, but yeah. Okay.
I thought that said I need a nap, but a wrap would be good
A
too.
wrap. Yeah. Oh, that was my favorite class.
We could do that as a final class. Everyone can submit it. Do like TikToks or something.
Yeah, it was brilliant. They would write the wrap as homework and then they'd perform them in the lesson. No one would ever forget the laws of indices.
That's amazing.
Yeah.
Okay, well, you can stop the screen share if you want, Amber.
Okay.
So we can see each other's. But equally, if there's no other questions, thank you so much for coming along. It was so nice to have so many of you on camera too. Again, that's not being mean to people who aren't on camera. It's just always nice to feel when you're the teacher, like you're not alone in space.
It's really nice to have everyone like participating
and loads of people. Yeah, I think a lot of the people who weren't on camera were like rocking the chat. They were like in there, and then we had Sophia writing on the screen. It was just amazing. So
yeah, definitely have to incorporate that into the next lesson somehow.
Yeah. Does anyone else know how she did? Do you guys know how she did that? We can. So she's got she's on an iPad and she's got a pen, but there is a section when the PowerPoint is up, there's a button that says annotate, and you can click it and draw on the screen. And that's what Amber was doing as well when she was writing things out. And we had been playing with it, knowing that students could do it, but we thought, oh, nobody will draw on it. Look at that. Sophia was right in there. So good.
Yeah.
So we can do that. I mean, it's up to you, Amber. I thought it was great.
I think it's great. Yeah, I like it. That's like really interactive then, isn't it? So
yeah,
absolutely. Do you have a pen, or I mean, it's hard, you can't really do it with a mouse, unfortunately. But if you've got an iPad,
you can do it. I mean, even on your trackpad, it doesn't write as nicely, but you can with your cursor, when you click annotate, you can do it just on your trackpad.
Yeah, just always welcome to go for it.
Looks a bit wobbly.
Yeah. Okay. All right, so I will pop that final slide into the where is the good place for me to put that? Is it
if you give me the slide, well, we can work out sort of, if you start posting in it later, I think that's something we have to figure out. But in the meantime, you can like send me the slide as a JPEG and I can put it up.
Brilliant. Okay.
As a post. And then also, does everybody know where the forum is in the class, by the way? You guys think people are starting to get it now because most of you registered that way, but it is in the introduction post on the main at the very bottom. It says forum to discuss all things maths. I might change the name of it to make it forum and like big up at the top, actually, because I think it's a bit hidden. But that's where I'll post the recording of this and where we can post any follow-up. And I know Amber will have access to it. So if there's questions, you can actually post questions there too, on those threads, and then we can follow up. And even if you go away and you're like, you know what, I still don't understand, I'm still not getting this thing, you could put it there and we can see if we can help out there.
Yeah, it's great for like students to chat to each other as well and help each other out. So
yeah, because probably one of you guys can answer it better than we can. That's always really helpful.
Yeah.
Okay, well, hopefully we'll see you in 2 weeks. Oh yeah, that I will just mention quickly, in 2 weeks, Amber is kindly coming to us from her vacation, her holiday in
Albania. Yeah, so
she'll be the exotic location. She is slightly worried about the Wi-Fi access. So if we discover that she is struggling and can't log in, you do not want me to substitute for her, because I do have a PhD. It's in the arts, and I couldn't answer any of the questions tonight. So, so what we will do is at that point, we'll bump the class forward to the next one. But fingers crossed, she'll be logging in and it'll all be fine and work fine.
Yeah, hopefully. Yeah. So, Okay, so I'll see you from Albania, the sunny Albanian Riviera in 2 weeks' time.
Okay. Good night, everyone.
Bye.
Thanks for coming. Great.